Welcome back to Java Internals Crashcasts. I'm Sheila, and today we're diving deeper into the fascinating world of garbage collection. We're currently in our advanced topics season, and this episode focuses on GC tuning and monitoring. Victor, are you ready to help our listeners optimize their Java applications?
Absolutely, Sheila. I'm excited to share some insights on this crucial aspect of Java performance. Before we begin, listeners should be familiar with basic GC concepts and the different GC algorithms we covered in our previous episode.
Great point, Victor. Now, let's kick things off with a quiz question for our listeners. Here's a scenario. You're running a high-throughput Java application, and you notice frequent GC pauses lasting several seconds. What's the first GC tuning parameter you should consider adjusting?
Ooh, that's a great question, Sheila. It really makes you think about the various factors that influence GC behavior. Without giving away the answer, I'd say this question highlights the importance of understanding the relationship between application behavior and GC performance. Listeners, keep this scenario in mind as we explore GC tuning and monitoring.
Excellent, Victor. Let's start with the basics. Can you explain what GC tuning is and why it's important?
Certainly, Sheila. GC tuning is the process of adjusting various JVM parameters to optimize garbage collection performance for a specific application. It's crucial because poor GC performance can lead to increased application latency, reduced throughput, and even out-of-memory errors. Imagine GC tuning as fine-tuning a recycling system in a busy city. You want to ensure efficient waste collection without disrupting daily life.
That's a great analogy, Victor. So, what are some basic GC tuning parameters that developers should be aware of?
The most fundamental parameters are related to heap size. We have two main ones, one for the initial heap size and another for the maximum heap size. Another important set of parameters controls the sizes of the young and old generations. For example, one parameter sets the ratio of old to young generation sizes.
I see. So, if we set this ratio to 2, does that mean the old generation will be twice the size of the young generation?
That's correct, Sheila. You're catching on quickly. Another crucial parameter controls the size of the survivor spaces relative to the Eden space in the young generation. Think of these spaces as different rooms in a house, each with a specific purpose in the garbage collection process.
Interesting. Now, how do we actually monitor GC performance to know if our tuning is effective?
Great question. Java provides several tools for GC monitoring. There are command line tools that display GC statistics, and for a more visual approach, there are graphical interfaces to monitor GC and overall JVM performance. It's like having different dashboards to check the health of your application.
That's really helpful, Victor. Now let's dive a bit deeper. How do we interpret these monitoring results to make informed tuning decisions?
Great question, Sheila. When analyzing GC logs or monitoring data, we look for patterns. Frequent minor collections might indicate that the young generation is too small. Long pause times during full GC could mean the old generation is too large or fragmented. It's like being a detective, piecing together clues to solve the performance mystery.
I love that analogy. So, based on these observations, how would we go about making advanced tuning decisions?
Advanced tuning often involves selecting the most appropriate GC algorithm for your application's needs. For example, if low pause times are critical, you might choose a specific collector designed for that purpose. You can then fine-tune parameters to target specific pause time goals. It's like choosing the right tool for a job and then adjusting it to fit your exact needs.
That makes sense. But Victor, I've heard that GC tuning can sometimes lead to unexpected results. Can you share any common pitfalls or misconceptions?
Absolutely, Sheila. One common misconception is that a larger heap always leads to better performance. In reality, a too large heap can cause longer GC pause times. Another pitfall is over-tuning. Sometimes the default settings work well, and excessive tuning can introduce more problems than it solves. It's like over-seasoning a perfectly good meal. Sometimes less is more.
Those are great points. Now, let's bring this back to a real-world scenario. Imagine we're running an e-commerce site preparing for Black Friday. how would we approach GC tuning for this high-stress situation?
Excellent scenario, Sheila. For a high-traffic event like Black Friday, we'd want to minimize GC pauses to ensure smooth user experiences. We might start by increasing the young generation size to handle the influx of short-lived objects from user sessions. We'd also want to monitor closely and perhaps use a collector known for its pause time goals. It's like preparing a store for a massive sale. You want efficient checkout, GC, without long queues, pauses.
That's a fantastic explanation, Victor. Before we wrap up, let's reveal the answer to our quiz question. What's the first GC tuning parameter you'd consider adjusting for an application with frequent, long GC pauses?
Great question, Sheila. The first parameter to consider would likely be the maximum heap size. Increasing this could potentially reduce the frequency of full GC events, which are often responsible for long pauses. However, it's important to note that this is just a starting point, and further analysis would be needed to optimize GC performance fully.
Thank you, Victor. To summarize today's episode, we've covered the basics of GC tuning parameters, explored monitoring tools, discussed advanced tuning techniques including GC algorithm selection, and highlighted the importance of careful analysis when making tuning decisions. Remember, effective GC tuning is about finding the right balance for your specific application needs.
Absolutely, Sheila. And don't forget, while GC tuning can significantly improve performance, it's not a silver bullet. Always profile your application and understand its behavior before making tuning decisions.
Great advice, Victor. In our next episode, we'll be exploring weak references and memory leaks, so stay tuned. If you've enjoyed this episode, please subscribe to Java Internals Crashcasts and leave us a rating. Your support helps us continue providing in-depth Java knowledge. Until next time, happy coding.